Hello, today I want to have a look at a high voltage power supply module. So this is a small module I bought online. You can get them on, I think I bought mine on eBay for about $15 US, but I'm sure you can find it on Amazon, AliExpress, Banggood, wherever you like to shop. So what we have here is boost converter, fairly high voltage, got adjustable output. So the specifications say input 12 volts. So that's over here, we will input 12 volts. Then we'll have a high voltage output here, and it is adjustable from 150 volts up to 420 volts. So we are talking fairly high voltages here, and something that is a little bit dangerous. So if you play with one of these, do be a little bit careful. But the nice thing about this module is that it's also got a low voltage section. So instead of being a boost converter, then we have a buck converter over here. And then we have an adjustable output here that will give us 1.25 volts up to 12 volts output here. The maximum current on the low voltage output here is 3 amps, and on the high voltage output is specified as 60 milliamps. So this means a small module like this, if it works as advertised, should be pretty nice if you want to play around with tubes, because the low voltage will be for your filament and the high voltage will be basically for your B+, and if you can adjust it, you can fine-tune your circuit. So if you're playing with Nixie tubes or something like that, or maybe you're building like a small preamplifier, then this sounds like it could be a good solution. But let's have a closer look at it and do some measurements and see how it behaves, if it lives up to the expectations. Also have a look at the layout, the design. Is it safe to use or not? I mean, the capacitor here on the output is 100 microfarad, 450 volts. That sounds okay, but that is a lot of energy stored in a capacitor here. So definitely we should probably never short the output here, because shorting a fully charged capacitor like this can be quite shocking. So having a closer look at the board here, it appears everything has been hand soldered, but it is reasonable soldering. I don't see any major issues, but there's some flux left over and things like that, giving an indication that it was probably hand soldered. As for the design, the only problem I can see is the high voltage, the feedback loop here. It appears that they are doing a voltage divider using some resistors here, and these are 603 resistors, surface mount, and they are not designed to deal with high voltages. I think 603 is like maximum working voltage is something like 75 volts, so trying to drop 300 or 400 volts over one of these small resistors here is not a good design. That is slightly dangerous. What they should have done is take 4 or 5 of these resistors and put them in series, so you kind of have less voltage drop across each resistor, and then it would have been just fine. So that's a bit of an issue. Is something that might be worth correcting, because that is not a good design. Okay, so I think now it's time to hook it up to the bench power supply and see if we get some voltages out of it, how it behaves. So I got everything wired up here. So first we're just gonna try switch it on with no load on it. So I have 2 meters, the big one on the high voltage here and the small meter here on the low voltage, and I have my bench power supply set to 12 volts. So let's try switch it on and see what happens. There we go. So we can see currently it's 267 volts coming out and 4 volts on the low voltage. So it doesn't come with any instructions, but I guess this is going to be the high voltage. This is going to be the low voltage. And then there's another potentiometer over here. I have no idea what it's for, but probably is for current limiting. Not sure how effective that's going to be with the big capacitor here. So I'm using a ceramic screwdriver to do adjustments here, because this is something you have to be a little bit careful. If you're using a metal screwdriver, it could easily hit one of the diodes down there or something like that, and there's gonna be like full voltage on it. Anyway, let's try adjust it here and see what happens. Okay, it's going down. Might take a little bit time to go down because there's no load on it, and we know this big capacitor here. It's going to take a little bit of time to discharge, but it's good to have a look. Below 200 volts. Well, let's try go the other way, see how high we can go. We're going up again. $300 volts, 380, 400, 450, 470, 480. That's a bit higher than advertised. It says it's only going to go up to 420. But anyway, that looks pretty good, and we can see even with no load, the main capacitor here is going to discharge fairly quickly. So let's try the low voltage and try to do some adjustments on that and see if it's working as expected. So I'm just using this potentiometer over here. 7, 8, 9, 10, 11. Yeah, so it's not going to go full 12 volts because we're going to have like a diode drop in there somewhere. And we go down, yeah, 1.25 as advertised. So that looks good. So I think let's try put some load on it and see how it behaves. So I've added a small load here. What we have here are two 100 kilo ohm resistors. That should give us 50 kilo ohm. And then I've added a capacitor and a 1 mega ohm resistor in series. That's just so I can hook up my scope, because I don't really trust my scope with high voltage DC. It's not really designed for that. So by doing this, we can block the DC and we'll just get the AC component on the output here. And then we have the multimeter hooked up as well here. So that should be a fairly light load. 2 times 50 kilo ohm at 400 volts should give us something like, what's that, 8 milliamps. So it should be a very light load. And then I want to have a look on the scope over here, just to see what the ripple looks like. So let's try switch it on. I have the bench supply set up over here, 12 volts, current limit 2 amp. Plug it in here, and let's try switch it on. There we go. And we can see currently the output voltage 172 volts. We do get a little bit of ripple here. Not too bad, considering it's 1 volt per division, and the actual voltage, the output voltage, is 172 volts. So anyway, let me try adjust it up. Let's try something like 400 volts. Increasing voltage here. 300. Oops. It's topping out now at 380. Well, that's no good. Don't really get any ripple on the scope, but that's a complete failure if we can only get 300. Yeah, now it's 375 volts with this tiny little load here. I mean, the specification says it's supposed to be able to deliver 60 milliamps, so that's a complete failure. That's pretty useless. I can see on the power supply here, it's currently just consuming 900 milliamps. So I wonder if maybe it's got something to do. Maybe there's like a current limit on this third potentiometer over here. Let me try. Give it some turns, see what happens. Try the other direction. That doesn't seem to do anything. Yeah, that's no good. So I wonder if we can try and increase the input voltage. I don't know if you can see it, but it actually says 12 volts down here. So I double checked the description in the eBay listing, and you can see it here. It says clearly input 12 volts. So yeah, not quite sure. I think we should try and give it some more juice and see what happens, because it's pretty useless like this anyway. So I've had a closer look at the components on the board here, and the input capacitor here is actually rated for 35 volts. This capacitor is rated for 35 volts. These two are rated for 50 volts, and this pulse width, or the modulation controller here, is a TL494. It is rated for up to 40 volts, and this one here, I believe it's a Texas Instrument, is rated up to like 37 volts or something. So I see absolutely no reason why the input voltage would be limited to 12 volts. So I'm pretty sure this was actually designed for 24 volt input. So that is what I'm going to try now, and then hopefully we'll get better results. Okay, so here we go. I didn't hear any big explosions or anything, so it seems to be operating fine at 24 volt input. Let's see if we can adjust the voltage higher this time. $300. Yes, it's looking much better. Let's set it to around 400 here. There's no real ripple, and the current consumption is less than half an amp at 24 volts. So that is looking a lot better. See if we can zoom in on the scope a bit here. So it appears the switching frequency is like 74 kilohertz. So this looks good. Let's try to add some more load, because this is only 8 milliamps load the way it is right now. So let's try double it, 16 milliamps, and see if it makes any difference on the performance here. I have added 2 more resistors here, so now we should have 25 kilo ohm load on it. So I'm gonna switch on again and see what happens. Okay, so we still have close to 400 volts. I don't see any real ripple coming out here. We do have switching noise, but it's actually quite low, all things considered. It's only about 2 volts. Let's see if there's some. No. It looks very well behaved, and 16 milliamp load is like that's probably fairly realistic load if you're building like a small tube preamplifier or something like that, maybe a phono amplifier. So that looks good. I think we need to try load it up even more. Okay, so I've added a new load here. It consists of 5 47 kilo ohm resistors in parallels. That should give us a little bit less than 10 kilo ohm load across the output here on the high voltage. So at 400 volts, that should be close to a little bit over 40 milliamps. So let's see how that goes. Yeah, we got our 400 volts here. Switching noise only increased it very little bit. It still looks very well behaved. However, the voltage is going down here again, so I do believe it's probably not able to deliver this continuously. So I hooked up a thermal camera as well. You can try and have a look at that. See, the resistors are getting really hot. They're about 200 degrees Celsius now. Other than that, we have the inductor, and then we have the switching MOSFET heatsink, but they're hitting like 100 degrees now, so pretty hot. This does not look like you can do this continuously. It's getting way too hot. Yeah, it keeps increasing. So let me try adjust the voltage down a little bit here. Let's say about 300 volts. So that means we're down to 30 milliamp load now. Yeah, I mean, the resistors are really hot now, but that's to be expected. So yeah, that looks like it can maintain that. So I guess that means the 60 or the advertised 60 milliamp output current is probably only something it can deliver at the very lowest voltage, and as you go up in voltage it will be able to deliver less and less. So yeah, that's not so great. I mean, if you cannot deliver 400 milliamps at 40 milliamps at 400 volts, then you're not going to be able to use it for any kind of power amplifier, but it might still be quite useful for preamplifiers, phono amplifiers, maybe even like a headphone amplifier, something like that. The output looks fairly well behaved. See, it's fairly stable. These are around 100 degrees Celsius now. The resistors, well, 235, pretty hot, but doesn't matter. Okay, well, let's do a test of the low voltage section now. I've added a load on the low voltage output. These are just two 2.2 ohm resistors in series. It gives us 4.4 ohm. So if we adjust the output to something like 6.3 volt, is a fairly common filament voltage, then that should give us something like 1.5 amp out of the low voltage. So I'm just keeping the load on the high voltage. I'll turn down the voltage a little bit, and let's see how this goes. I'll switch it on now. Okay, just adjust the voltage over here. Okay, that should give us about 1.5 amp here. Looks like no problems. Perhaps we should have a look at the thermal image again and see what's going on there. Yeah, you can see it's starting to heat up over here, and we can see the load here is heating up as well. But that looks okay. I don't see any problems here. Okay, let's do a quick conclusion on this little high voltage power supply module here. One of the biggest problems, I think, is the 1 mega ohm resistor here that is creating a voltage divider together with this 220 kilo ohm resistor here, and it's dropping the full voltage across these two resistors. They're simply not designed for that. It's dangerous, and you could fix the problem if you can replace it with something like this, like a 3 watt 1 mega ohm resistor, but going from a 603 package to a 3 watt resistor is probably not going to be that easy. It might be possible to do it somehow, but I'll definitely recommend doing something about it, because this is it's not great. Other than that, I would say it was a bit of a disappointment that the input voltage was advertised at 12 volt, but it's not going to work very well at 12 volt. It needs at least 24 volt to work correctly. You might be able to go higher than 24 volt, but I wouldn't go much higher than 24. So that's like falsely advertised. And also, I would say the output current capabilities on the high voltage, it's incorrectly advertised. We could see at 400 volt, we're not going to get more than 25 milliamps out of this supply here. At 300 volt, we'll probably get about 30 milliamps out of it. So that's a lot less than the 60 milliamp that was advertised. It's kind of too bad. They could just advertise it correctly, then that would be, at least you know what you're buying, right? Here it's like maybe you buy it for a specific purpose and then find out it's not going to work because it's advertised incorrectly. Other than that, I would say the high voltage output seems to be very well behaved. I didn't see any problems there. There's one other negative. I noticed that even though the listing said you can only adjust it up to 420 volt, I actually noticed that I could get it all the way up to near 500 volts, and that is getting a little bit dangerous because this capacitor here is only rated for 450 volts. So I certainly don't want to be around if this thing explodes. There's a lot of energy in there. So I would say cannot give it a thumbs up, but I wouldn't give it a thumbs down either. If you know what you're getting, then this is a lot of high voltage power supply for $15, and including a filament supply as well. So getting hold of proper high voltage power supplies these days is not that easy, so this is a reasonable alternative. If you want to play around with some Nixie tubes, or you're building a tube preamplifier, phono stage, headphone amplifier, but it's not going to be able to drive a power amplifier. Even a small power amplifier, I don't think it's got the grunt needed to supply the tubes in a power amplifier, and certainly not a larger power amplifier. The low voltage section seems to be like no problems there. So final conclusion is going to have to be a thumb sideways. Anyway, thanks for watching. I hope you enjoyed the video, and I'll see you next time. Bye bye.